What is differentiation? In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate of change of displacement with respect to time, called velocity. The opposite of finding a derivative is anti-differentiation.
When do we apply differentiation? Differentiation can help us find increasing and decreasing function and stationary point, maximums, minimums, and point of inflation. For the example, y equal to x has derivative negative ones, which is always negative, and so x is decreasing. We know that at stationary points, dy over dx equal to 0, since the gradient is 0 at stationary points. At maximum points, the gradient is positive just before the maximum. It is 0 at the maximum and it is negative just after the maximum. At minimum points, the gradient is negative, 0 then positive. Finally, at points of inflation, the gradient can be positive, 0, positive, or negative, 0, negative.
Real-life application of differentiation. With the help of differentiation, we are able to find the rate of change of one quantity with respect to another. Some of the examples are acceleration, rate of change of velocity with respect to time, to calculate the highest and lowest point of the curve in a graph, or to know its turning point, the derivative function is used. To find tangent and normal to curve.
Related rates of change. What is related rates? Related rates and problems involving related rates take advantage of quantities that are related to each other. Related rates help us determine how fast or how slow a certain quantity is changing using the rate of change of the second quantity. For the example, the amount of air present and the shrinking of or expanding balloons volume will change over time. We can express the shrinking balloon's radius and volume as dr over dt and dv over dt respectively. When the balloon is expanding, both dv over dt and dr over dt are increasing. Similarly, both dv over dt and dr over dt are decreasing when the balloon is shrinking.
For example, as time progresses, the water level within the cylinder increase. This also means that the volume of the water inside will be carrying with respect to time. We can use related rates here if we want to observe the rate of change of the water level, height, and volume with respect to time. We can assign h to be the water height, so its rate of change will be dh over dt, where dt represents the change in time. Similarly, if we assign v to be the water volume, we can represent the volume rate of change as dv over dt. The two rates, dh over dt and dv over dt, can then be used to determine unknown values or quantities.
Assalamualaikum warahmatullahi wabarakatuh.
My name is Muhammad Shafiq Aziz from PEE 111A2. I want to present my video of calculus and my solution. Okay, our solution. Okay, then today I will explain our solution. So this is what we get of the question. The conical plane has a radius. Radius of the conical plane is 1.5 meter, and the height is 2 meter. And the rate of water leaking, dV over dt equals negative 0.25 meter cubic over minute. Height, and then height of water is 1 meter. As a question, we need to find the formula of code, which is 1 over 3 pi r squared h. And then we use the geometry of the code, r over h, to find r in terms of h, to substitute it into the formula. So when we get the value of r in terms of h, we substitute it into the formula, and then this square. So we expand like this, then it become like this. Okay, finally this h also get into we expand the equation, and this is the final answer. So we differentiate this equation and get dV over dt equal to 0.5625 pi h squared dH over dt. So when we get this, given that dV over dt equal to negative 0.25 and height of the water is 1 meter, like this. So we substitute it into this equation. So negative 0.25 equal to 0.5625 pi, and then substitute 1 into h, and we get negative 0.1415. So this is the answer for question A.
So we want to search the radius of water. First of all, we take the r equal to 0.75 case, and we substitute in the bracket A to negative 0.1415, and we
multiply.
and we multiply it, and we get negative 0.1061. So that's it from our group.
Okay.
Bye-bye.
For conclusion, differentiation is a important technique in calculus that enables us to determine the rate at which a function change. This can help to know how gx behavior or solve related problem like finding critical points. Thank you.